Hey class, Mr. Hanji here. For today's lesson, we're going to be talking about section 12.1, which is going to deal with Triangle Proportionality Theorem. Now, for today's lesson, you have one learning goal, and our learning goal for today is that you will be able to use the Triangle Proportionality Theorem to find measures of side lengths. So we're going to talk about the Triangle Proportionality Theorem, then use that theorem to help us to find the length of segments, and then also use that theorem, the converse of it, to prove that two lines are parallel. So, with that said, let's go ahead and get into our lesson for today. Now, I've mentioned the Triangle Proportionality Theorem, so let's go ahead and talk about what it is. So, the Triangle Proportionality Theorem states this, that if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So, what this means is if we have the triangle ABC and the line EF cuts through the triangle, if EF is parallel to BC, then EF is going to divide these two sides proportionally. That means that it's going to cut AB into AE and EB and AC into AF and FC, and that those parts are going to be proportional to each other. In conclusion, that means that I can set it up as AE over EB, so small over large on the left side, equals AF over FC, small over large. So you can take a side, if it's been cut into two different parts, you can take the smaller over the larger and set it equal to the smaller over the larger, or larger over small equals larger over small. So that is what the Triangle Proportionality Theorem states and allows us to do. Unlike with Module 11, we don't have to take AE and set it equal to AB, or take AF over AC. So we don't have to do small over the whole, small over the whole. We can take this part over this part equals this part over this part. And the reason we can do that is the Triangle Proportionality Theorem, and because EF is parallel to BC. So, with that said, let's go ahead and get into practice for example 1. Alright, example 1 is going to ask us to find the length of each segment. So if we look at A, they want us to find the length of CY. So that is going to be our goal for this problem. Now, first thing you need to do is just identify that the line cutting through the triangle is parallel to the third side. So we see that XY is parallel to BC using those two arrows. So given that, we can then use the Triangle Proportionality Theorem to go through and figure out what CY equals. So, Triangle Proportionality Theorem states that we would then take BX over XA and we would set that equal to CY over YA. So now that I have that proportion set up, we can just plug the values in and then solve. So BX is 4, XA is 9. We need to figure out what CY is, and then we know that YA is 10. So we have 4 over 9 equals CY over 10. So from here, all we have to do is just cross multiply and solve. So if we do 4 times 10, we end up with 40, and then 9 times CY is just 9 times CY. And then from there, all we have to do is just divide. So you just use your calculator. And if we do 40 divided by 9, we end up with 4.4 repeating. And that is the length of CY. Now, if they wanted this to be in a fraction, that would be, and that didn't take it how I wanted it, but it would be 4 4/9 if it wanted it as a fraction. And that is our answer for A. So let's go ahead and practice another one. If we look at B, so we need to figure out the length of PN, so that blue side length right there. So if we take LP over PN, that's going to be 3 over PN equals 2 over 5. Small over large, small over large. So we have 3 over PN equals 2 over 5. So if we cross multiply, 3 times 5 is going to give us 15. And then 2 times PN is going to give us 2 times PN. So we have 15 equals 2 times PN. So then all we have to do is divide by 2. 15 divided by 2 is going to give us 7.5 for the length of PN, or 7 1/2. And that's our answer for part B. So example 1 is just simply that, where you're going to set up a proportion of this part over this part equals this part over this part. Same thing we did over here, where it's this part over this part equals this part over that part. All right, now for C and D, it's going to be much of the same, but I am going to talk about something slightly added on with it to adjust it. Now, from what we had talked about up above, okay, it was doing this part over this part equals this part over this part, but we can go side to side or top to bottom. Doesn't matter if you just stick with the same side. You just either have to do same side, or top, top, bottom, bottom. Okay, so you just have to keep that same order for both proportions. So up above, like we did with B, we would normally set this up as 32 over 24, except this time I'm going to do as 32 over 40. And then, so we did top, top. So if we do bottom, bottom, it would be 24 over DG. So now that I have my proportions set up, we can go through cross multiply and solve. So if we were to do 40 times 24, we would end up with 960 equals 32 times DG. So if I have 960 equals 32 times DG, all we have to do is do 960 divided by 32, and we would end up with 30 for the length of DG. Now, just to quickly point out that it does work whether you do side to or top, top, bottom, bottom, or left, left, right, right for your proportions. Just want to run through it. So if we did 32 over 24 instead of 32 over 40, and then 40 over DG, we would do 24 times 40, which would give us 960, 32 times dg. And as you see, this is the same that we get up here, which results in giving us 34 dg. So it doesn't matter which way you do it. You can either, keep to the same side or cross over, just as long as you're not crossing across the triangle. So if we look at D, you could set it up as 8 over 5 equals 10 over Rn, or you could do 8 over 10 equals 5 over Rn. Now, up above, we would have done 8 over 5 equals 10 over Rn. I'm just going to run through it, though, by doing 8 over 10 equals 5 over Rn. So now that I have my proportion set up, if we go through and multiply, 10 times 5 is going to give me 50, and then 8 times Rn is just that. And then all I have to go through and do from here is divide. So if we do 50 divided by 8, we get 6.25 equals Rn, or 6 1/4. And that's our answer. And that is going to be how you go through and use the Triangle Proportionality Theorem to go through and find lengths of segments. So again, you can either set it up like we did with A and B, where we did 4 over 9 equals cy over 10, or 3 over pn equals 2 over 5, or we could do 32 over 40 equals 24 over dg, or 8 over 10 equals 5 over Rn. Either way works, as we saw with parts A, B, C, and D. That is just using the Triangle Proportionality Theorem, where the line that intersects the other two sides is parallel to that third side, and it's going to divide those two sides proportionally. And that is example 1, and that is the majority of your homework for today. Now, one last thing to talk about before we end our lesson for today, for 12.1, and that is going to be the converse of the Triangle Proportionality Theorem. Now, if you think back to Geometry A, whenever we talked about the converse, it was just saying the same thing, but in reverse. So the Triangle Proportionality Theorem stated that if those two lines were parallel, then it divided the sides proportionally. So the converse states that if a line divides the two sides of a triangle proportionally, then that third side is parallel to it. So really what we need to figure out is if EF divides these two sides proportionally, then we can say that these two lines are parallel. Okay, if we look back at example 1, okay, if you look at parts A, B, C, and D, okay, BC is parallel to XY, LM is parallel to PQ, CD is parallel to FG, and QR is parallel to PN. So what we are going to go through and do for example 2 is we're going to take the idea that we don't know that these two lines are parallel, so we can't use that, but we're going to take the fact that we know all the measurements. We're going to determine if the sides are proportional, and if they are proportional, then we know that the two lines are parallel. So, if we look at example 2, part A, we need to verify that the line segments are parallel. So we need to prove that MN is parallel to KL. So we're going to go through and show that these two sides are proportional. So for part A, what we're going to do is just set up KM over LN. So 21 over 15, and that's going to be equal to mj over nj, which is going to be 42 over 30. Now, two ways we can do this. We can simplify these fractions, or if we just cross multiply real quick here. So if we do 21 times 30, we get 630. And then if we do 15 times 42, we get 630. So because we cross multiply and we get the same number, that tells us that these two sides are proportional. So because those two sides are proportional, then we can say that MN is parallel to KL. And that is our answer for example 2, part A. Now, briefly, just to talk about part B, just to give you another one to reference. Okay, if we look at B, so we need to verify that TU and RS are parallel to each other. So before, over here I did top to bottom, top to bottom. So this one, let's stick with top, top, and then bottom, bottom. So if we do 90 over 72, we need to figure out if that is proportional to 67.5 over 54. Now, a couple of ways you could do this. We can cross multiply like we did, or you could just go through and divide to see if you get the same number. So if we divided, just as a reference, if we did 90 divided by 72, we get 1.25. If we did 67.5 divided by 54, we get 1.25. So that would be one way we could do it, or you could cross multiply to do the 90 times 54 and get 4,860, or 72 times 67.5 and get 4,860. So because I get the same number, whether I divided or I cross multiplied, that means that these two sides are proportional. So that means that TU is parallel to RS. So unlike example 1, where we're using that concept that two lines are parallel, that tells us that the other two sides are proportional to find a missing side length. This time we're using those two side lengths to then tell us that the other two sides are parallel to each other. Example 1, we start with the concept that the two lines are parallel. That tells us the sides are proportional. Example 2, we start with the sides being proportional to tell us that the sides are parallel. So, with that said, C is much of the same, so I will leave that one for you guys to do on your own. I think this one should be pretty self-explanatory for example 2. Otherwise, that is it for this lesson on section 12.1, dealing with the Triangle Proportionality Theorem. And that is it for today. So thank you guys for listening. As always, if you have any questions, you can always let me know via email or next time you see me, and I'll be more than happy to help however I can. Otherwise, that's it for our video today. Thank you for listening. Be sure to reference back while you're working on the homework if you need help, or you can always reference my completed notes as another guide while you work on your homework. Otherwise, that is it for today. I will talk to you guys later. Thanks for listening. Have a great day, and I'll see you later.